Okay, hello, everybody. Today we're going to start off with David Pepper doing a little bit of the weather, and then I'm going to continue doing a little bit of miscellaneous. So we'll share the screen here, and we hope you'll see only one slide. And
Oh, we're not doing Crimean weather.
It's a cloudy there these days.
Yes. Okay, I hope you're only seeing one picture, are you?
Yes.
Memorable too.
Yeah. This is our driveway. David thought we should lead off with that. We were marooned for about 2 hours, and we're recovered. But enough about me. Let's see. I gotta turn this caption thing off. It always does it.
Yeah.
Okay. So I hope that
Back one.
back one.
That's it. There you go. That's the one.
Okay. So and now we're going to go to the next one, and David, you're going to take over, right?
Yeah, I can, well, you can do the slides, but can everybody hear me?
Mm-hmm.
Okay, so John asked me to talk about atmospheric rivers a little bit. And just because the weather is so up right now. So this could be lengthy, but I'm going to try to keep it short, but it's more pictures and what I think is a fun website. So, you know, I think Homer, you guys were just talking about how you just got stuck in a, hold on, we're having technical difficulties. But you got stuck in a downpour, and I think what everybody realizes, and we realize much more and more, is that weather is not this homogeneous thing, particularly in the Bay Area. But you know, in many places, this term atmospheric river has become popular, which I imagine most people have realized or have heard about. And so I thought I'd just do a little bit to explain it, and I'm going to use some pictures from one of my favorite web portals that shows you the densities of water, and then we're actually going to go to the site, and then we're gonna and then we'll talk about it. So you know, if I said atmospheric river, what is that? What do people think about?
Well, I think about a series of water-laden clouds, one after the other, moving like one after the other, like a stream of water-laden clouds, like a river.
Perfect, exactly. Or some people think of it as a snake going through the sky, and it's, you know, heavily laden air which is carrying water. And of course, most people may remember back to physics, but air is a liquid as well. So the humidity, the relative humidity, is just this mixture of a lot of density of water that when it's going across the ocean,
Yeah, you're still on.
okay, when it's going across the ocean, we don't see it, but once it hits land, of course, we see it or we feel it. And it's not like it's a river in the sense that it stays in its channel. It's more like if you imagine a big parking lot, and at one end of the parking lot, you just took a huge bucket and you dumped it. Well, it would sort of slosh to one side and to the other. And if there was a little wind, it would go one way and then it would go the other way. And of course, there's huge winds in the atmosphere. So these rivers get buffeted around, and the National Weather Service does its best to predict which part of the river is going to hit which part of the land. And that's,
we're not seeing any images. We're not seeing slides. We're seeing John and his wonderful beard.
okay, hold tight.
Yeah,
The river's coming through. Gotta go share screen.
Hold tight.
There we are on the left, John. That's it. See if this helps us. Oh, you may have to lift that whole thing up to get to the share screen button.
I see. We got a problem.
We'll just grab it and grab it and
Wait a minute.
click and hold it. There you go. Hold on.
The problem is we're not at the meeting.
What?
Where I can't get back to that screen.
There it is down there, the black thing.
Right, the one that's blue. There you go. Now click share.
Now,
Are people still with us?
Yes.
Okay.
We are.
All right, now let's see.
No, we still
Good.
see the presentation view.
Okay, let's go to the slideshow now, John. Play from current slide. All right, let's see what we got now. All right.
That's it?
Okay,
There we go. Okay, so this, and these aren't in exact chronological order, but this is what was happening last like Friday, Friday, Saturday. So this, if I use this huge amount of water this is the Bay Area, was kind of coming right at us. And you can see, so this looks a little more like we might think of a river, but then this is almost like a hammerhead. So it's not just one river, I guess is the way to think about it. So it was coming pretty much right at us, and there was severe weather, and there was an incredible wind. Oops, John went forward a little. But if you remember the windstorm, and of course what happens as this water is moving towards us, it pushes the wind in front of it. So a lot of times, right before a storm hits, there'll be an incredible amount of wind because the water is pushing the wind and has to push it out of the way. And that happens. And that's what happened when we had those incredible winds last week. And then, they thought this was going to just inundate us. But in fact, this is it getting very close to the Bay Area. And then it just parted. So now you can see on this one, this is the Bay Area right here. And the bulk of the water went to the north and to the south. So the Santa Cruz mountains got slammed, up to Eureka and Humboldt got slammed. But that what had looked like was going to just crunch us kind of didn't do quite as much. I mean, it still was a big water thing. Then it all cleared. And then this next thing was coming. And then, so this was my attempt to capture an atmospheric river. This was the front edges from it. If you see this kind of gray, long thing, you can almost imagine a river, a river in the sky. So this is actually from our apartment. And I don't know if that makes sense to people, but these things can be 1,000 miles long and 100 miles wide and, 4 miles tall, with just incredible amounts of water. The energy in these is something like, 10,000 nuclear bombs. Because, somebody thought, oh, we'll just put a nuclear bomb and blow it out of the way. And there's absolutely no way that the amount of force in this is just almost.
So we're looking at the top of the stem cell research building at UCSF.
No, this is actually from that's Children's Hospital. So you're looking west. To the right is this is Mount Tam right here. And this is downtown San Francisco over here on the far left of the screen. So you're looking from Oakland to the west. And you're seeing.
I got it. Children's Hospital, Oakland. I got it.
Right. Children's, we're in Oakland. So, and the other thing that, in the Bay Area, we have a very unique chance to see is the fog. So I don't know if everybody is in the Bay Area or spend enough time here, but, we often see the tongue of fog coming right through the gate. And why is that? Well, water is heavy and it likes to sink. And so it's going to find the path of least resistance. Fog is water-laden air. Not like a rainstorm, but it condenses out. And so we see the fog. The other thing you'll see is that the other thing to remember is as air rises, it cools. So sometimes you won't see any fog, and then just when it hits the land, it'll start to rise up and condense. And there's a lot of phenomenon around the air, water-laden air meeting the coast, because all of a sudden there's a change in the topography. Things get pushed up and it condenses out. People may know, but the Bay Area has 50 microclimates. So if you were to tell somebody from Chicago that if they were to drive 10 miles in any direction, they could go through 3 or 4 weather zones, that one area gets, 40 inches of rain, Kentfield, and another gets 20, San Francisco, and they're separated by about, 8, 10 miles. People wouldn't know what you're talking about, because, in the Midwest, where it's flat, the river doesn't get bumped around and lifted and shifted and dropping its water. So if anybody's lived in other places, they would know more. The weather forecast is the same throughout most of the Chicago area. Mountains, Colorado, obviously different, but the Bay Area is very unique in that we got this huge ocean to the west of us, which is an incredible source of water vapor and storms that either come from the north or come from the west. These are coming mostly from the west. And when they hit the land, they get bumped up and around. If it's a massive river, which is what we're seeing, it gets bumped a lot less, but it still does. And I think next slide. Yeah, this is just more, visions. And next slide, I think this is a couple days out. The other thing, and when we go to the website, I'll show you, is most of the weather comes from 30,000 feet up. The big atmospheric rivers aren't cruising along the at 5,000. They're much taller, and they're pushed around by the Coriolis, the big winds of the planet. I think is there one more slide? Oh, well, this is just to show you that this is the reservoirs. We've had 5 years of drought, and that's why everybody's all excited or flabbergasted by all this crazy weather. But we're still well behind. After this next week, the reservoirs will probably be full. The reservoirs are about 1/3 of our water. The other 2/3 is in the snowpack, which we're also doing pretty well in.
Yeah, I thought they actually kept the reservoirs kind of low at this time, anticipating the melt of this 174% of usual snowpack we have.
That you're entirely correct, Homer. It's a game they play, because if they let go of water, but then there's a drought, then everybody yells at them. And if they keep the water and then there's a flood, everybody yells at them. So, but you're right. It typically in December, our big 3 months for rain are December, January, February. We get about 75% of our rainfall in those 3 months, typically. Now, one of the things with global weirding, and I do a lot of weather stuff, around the climate changes. We've been calling it global weirding for a number of years, because it's not like it's just getting a little wetter or a little warmer or a little colder. It's the fluctuations are happening, and there's enough physicians in the audience to realize this. But about 85% of the energy that's been produced, the heat energy that's been produced, has not heated up the air. It's heated up the water in the ocean. So the ocean is absorbing most of it, and the same is true for the CO2. So while people cite the 1 degree Celsius temperature rise, so that would be taking somebody from a 37 to a 38, which would be mildly concerning as a physician. The other thing is the pH of the oceans has changed 0.10, taking us from a 7.40 to a 7.30. And again, the physicians, Homer, I'm sure you could well recognize that if I told you your patient had a pH of 7.3 and a temperature of 38.1 and rising, you'd be pretty concerned.
I would.
Especially if you knew the cause was not changing. I think that's it on the slides, John. Is there one more?
Let's see.
I think then the next one's this was last week's slide, a little on the water. And I just from perspective, look at the West Coast, right? Comparatively, these are volume comparisons. So the Columbia in the Northwest gets a ton of water, but California really gets a fairly small amount of water. The Colorado down in the left is where about half of California's water comes from, almost most of Los Angeles, San Diego. And then for comparison, look at the Mississippi. And John had asked me, or somebody asked a question last week about the Amazon. So I did a little, the Amazon is about 10 to 12 times the volume of the Mississippi. So just, water-wise, California and the whole Southwest historically has been a fairly parched area. And it's only been, some people would argue, the last, 50, 60 years that we've harnessed the water and dammed up the Colorado and diverted it. And we've been living a little bit on borrowed time. Next slide. And is there one more?
I've got the dumbest question you're ever going to hear.
Okay.
Don't build a canal from the Mississippi to California.
Well, you'd have to pump it over the mountains. Right? The Colorado, the Rocky Mountains are in the way.
You could go down, you could go down.
Well, the amount of it,
south.
Bob, it's not a dumb question. It's been thought about. Why not come from the Columbia? It's closer. And there's plenty of water in the Columbia. Again, you have to go over the mountains of Ashland and the 5,000-foot mountains. Now, when they went from the California Central Project, they did go over the Tehachapi's. They do pump the water up from Sacramento, basically, to get it over the mountains to go to Los Angeles. But it's a fairly small amount to feed the people. So projects have been thought about. There's a project to consider towing an iceberg down from Alaska and then putting a pipeline in it. Serious about 20 years ago.
That's really serious.
But of course, all these take a tremendous amount of energy. And but the Mississippi is an incredible amount of water. And anybody, I went to med school in Iowa, and anybody from the Midwest knows, there's no problem with water in the summer. It rains almost every day. Getting that water to where California wants it is, so it's not a dumb question. Bob, I used to say there are no dumb questions. The only dumb question is the one that was just asked if you weren't listening and you repeated it. So question accept. Are there other questions?
Well,
I go.
I read that, we most of the rain that falls, a lot of it just goes into the ocean. So we're not capturing as much as we think we're capturing.
Well, California, so we've got 3 big reservoirs in the North Shasta Trinity complex. And, the Sacramento River is nowhere near as big as it used to be, because we do capture, I think it's something like half of the water is captured. So
You mean the rainfall?
the half of, rain and snow. Because of course what happens is the first rainfall, as Bob said, or Homa did, fills up the reservoirs, and then they hope to keep 2 more fillings of the reservoir in the snowpack, which is why the snowpack's so important. And then as it melts, then it goes into the reservoirs, and then they take it down and pump it. But we harness California. People are always, say, why don't we build more dams? We have about 90% of the rivers dammed. Now the rain that falls into the Central Valley, which is not a ton, but the rain that falls into the Central Valley and flows out to Sacramento River, we don't have a dam to stop it. But they do pump the water. They let the water come downriver in the Sacramento, and then there is a pump system that takes it under the Delta. So California is very efficient. California and Israel are the 2 leaders in the world, in part because they're both very arid Mediterranean climates that don't have summer rain. Does that answer that? Yeah.
So I've got one more dumb idea to dispose of. We went up to Gualala for a Christmas vacation a year ago. And a dumb idea was to take water from the Gualala River and put it in giant bags and float the bags down to Southern California. We have a neighbor who had a house at Sea Ranch. And this was a coffee table book that was right there. And our neighbor made this famous people from Mendocino and what they had done. And because he was up at Sea Ranch, so near the Gualala River, he and his buddy launched a campaign against this stupid idea, and they won. All right, so I'm sure there's more stupid ideas.
Well,
out there.
but again, look at the picture of the United States, and Bob's going after the big blue, Mississippi, but the second big one would be the Columbia. Next to that, there's not much in California. The San Joaquin, the Sacramento are relatively small in comparison to flow.
There's the project that I've liked the sound of, maybe it's crazy, but is covering up the aqueducts, the open aqueducts, with solar panels to reduce evaporative loss.
Yep.
And to generate energy to reduce global weirding.
Yeah, very sexy. Of course, building and supporting a structure over water would be tricky, you know,
Like bridge.
and and accessing it to fix it would be a little tricky. But yeah, that has been talked about. There's also projects to float plastic white or silver balls on many of the reservoirs to reduce the evaporative loss, because we do lose quite a bit by evaporation. But those are all fairly small compared to the real issue of California as a desert, and we just don't have a ton of water.
We're ready to go to the video.
I think so. Yeah, is that the last one? I just want to make sure it's the last slide.
I think so.
Oh no. Well, this is, so we're going to go to this website too, but I take great fun in watching this. This is the 10-day weather forecast.
Are you guys seeing this?
Not now.
Not yet. We see you again.
Uh-oh. All right, hold on. Late from slide.
I thought we were done.
Okay, that's fine. This one on the left. Oh, you gotta go to share screen. You gotta go down.
Bring it up.
Bring it out. There it is. There. So the 10-day weather forecast, which are the National Weather Service. Are they not seeing it?
We're getting something.
Well, we've got presentation view again.
There, it's down there.
She wants presentation.
Yeah, from the bottom.
That's there. It's not screen.
Oh,
Slideshow.
Slideshow.
Up here, slideshow.
Where did it go?
To the left there, to the left. Slideshow. There you go, that one.
Okay.
And now there. Let's see if this works. Are people seeing a sort of a 7-day rain forecast?
Yes.
Yes.
Okay, so this is from well, we're already here, and this is from a couple days ago. But you know, the thing to know, this is your rainfall, so pretty steady rain for the next 10 days. But what you'll note is, you know, half an inch, quarter of an inch, 2/10 of an inch, third of an inch. It looks like about, you know, half an inch a day. You know, but as Homer and Jenny just drove through, that might mean half an inch in 10 minutes and then very little for the rest of the day. Because when you are walking through the river, as if you're walking through, you know, out of John and Aiko's street, and you go right through the river, you're going to get really wet really fast, and the rest of the land won't get much. All right, let's go to the website. So there's 2 websites, and then I'm done. The one is where the first images came from, which is Null School. You know, so it just amazes me the amount of amateur meteorology I can do. I have two friends who are professional meteorologists, and I get additional fun from them. Let's see, is it a share screen?
And,
Share screen. There you go. Yep, that's it. You got to raise it up again so you can share. Let's see.
okay, well, I hope you're seeing a video.
It's sort of a. Is this? Are you seeing some? Click on Earth here. So, are people seeing a couple blue atmospheric rivers?
Yes.
Yeah.
Okay,
yes.
and the green circle, that's us, just for perspective. So this is the whole Pacific. And this is what's coming. This is right now, right here. Now, I'll show you in a sec, but this is probably at an elevation, because as I said, these rivers come not at sea level, but come, you know, 10, 20, 30,000 feet. But now you can look at this, and if you see this blue one that's closer to us, and you look at these winds, you say, well, this looks like it might drop to the south of us. But of course, water has its own momentum. And if I go to this one, you know, if I look at the surface, the winds are very different, much slower. But if we split the difference and go up, say 10,000, all of a sudden, you see this, what looks like headed right at us. And there's a very low pressure here that's kind of pulling it to the north. There's that discussions of what bomb cyclones are. They're basically kind of a hurricane from the north that is causing a pulling down of the polar vortex. But this is headed at us. And then there's this big one out here. Now, what you'll see is that if you were to watch this, as I started with, this might totally change in 24 hours. Now you look at this, and if you're standing right, if this green dot, and you looked at those lines and you said, wow, if that river came right at us and we were standing in that river and it came right at the Bay Area, we might get 10 inches of rain. There's one of my buddies who thinks that there could be up to 10 feet of snow in the Sierra in the next 5 days because of this. Now, it could also do what that last one did, which is turn totally sideways. And then, of course, you're not walking down the river and in the river, you're walking across the river. So you might get an inch of rain. This changes and it's very dynamic. But this is what, when they talk about a series of atmospheric rivers lined up and pointed at the Bay Area, this is what they're looking at for this next one. And then this is the even bigger one that's out here. Question, Michael.
So then, is it the wind that changes the direction of the atmospheric river?
It's both. So the water has its own momentum, and the most advanced computers in the world are the National Weather Service. They use the most advanced, they tap into, and they're not perfect. It's such a, I mean, again, if you look at this one here, there are, gigatons of water moving at, I don't know, 10, 12, 15 miles an hour. But as anybody who's been in a rainstorm knows, it's not like it's just coming down. It's blowing to the side. It's going this way and then that way. And it's not a homogeneous thing. So yes, the winds are pushing it. The winds, in this case, the winds are at 850 kilobars. As we go up, the winds, they look about the same there. But if we get up to really higher winds, it looks like it might push it south. So the computers attempt to model this in 3D. And in the ocean, it's a little easier because it's flat. There's no mountains. But as soon as it hits the coast, it starts getting pushed around and bounced around. The reason the coasts take the brunt of it, and then the Sierras, is because as it goes up, the water gets dropped out. It cools down. And so the rain is always on the western side of the mountains. So, for example, Oakland's getting quite a bit more rain than you guys are here, although you're on the edge of Diablo. And the same thing is true of the Western Sierra. The western slope gets far more. And if anybody goes to the east side, it can be almost dry there. So it's when it hits the land, it changes. And out in the ocean, it's the way the water is moving, the way it's swirling, the way the winds are buffeting it. And there's what's called the Coriolis effect, which is because the earth is turning at 25,000 miles an hour, not 25,000, 12,000, 1,200 miles an hour. The atmosphere literally gets ripped and pulled back, so it creates these very high winds. It's why it takes an hour longer to fly from New York to California than it does from California to New York, because literally they're going into a 200-mile-an-hour headwind the whole way.
Jet stream.
The jet stream is a simplification of the winds up at an altitude. If you want to make things more fun, you can.
Oh, fuck yeah. I'm loving every second of it.
So this is another view, and John sent this out,
Yeah,
but
you don't want me to turn it off? It's got to do with
somebody.
he's got a meteorologist on. He's explaining the jet streams that are responsible for this.
Okay, Pepper's been promoted to meteorologist. We can hear you,
Actually,
Rob.
I would go to. I'll take climate scientist, because truth is about half of meteorologists don't have college degrees. It's really stunning how much. Yeah, their meteorologists are getting better, but they look at the national weather. Here's the Earth. So here's currents. So when you talk about ocean currents, people have heard, and Al Gore made famous this current on the East Coast that goes up the East Coast,
The Gulf Stream.
the Gulf Stream, which comes up from the Gulf and buffets the East Coast in warm water. You can see the red is the warm water here. There is a current that comes down the California coast, but it's nowhere near as big. And then you can actually do things like go to sea surface temperature anomaly. So this shows you how much warmer the East Coast water is normally to what it should be for this time of year, and how much colder the West Coast is. That also affects the weather, Iko, because if you have warmer water, there's more evaporative energy.
No, I can't.
All of a sudden, the water is there's more water coming up out of the ocean from the bottom. So that river, that atmospheric river, is being pushed around, in the ocean by evaporative forces, by wind forces, and by its own momentum as the water moves.
Can I ask you one more question?
Yeah.
The water that's in these clouds are salt water, right? Because it comes from the ocean.
No,
Oh, it isn't?
no, salt, whenever you evaporate the ocean, the salt stays behind. It's too heavy, yeah. Salt is much heavier than water and it doesn't evaporate.
So it's not salty
No.
water. It doesn't change the pH. or-
No. I mean, if you go to the coast and you stand 10 feet up from the water, you'll taste a little salt. But when the rain comes, it's not salty. It's pure water. Yeah. We do get there's some parts
This of the ocean.
and not salt.
Pull us back into the ocean.
That, and John, maybe just go to the last one, go to the weather underground,
A little bit yellow.
just top right up here.
Me?
Just switch, yeah, right, keep one of the right.
No, I've got to
You gotta stop, okay,
I've got to do stop share. I've got to.
okay.
It's a
Change
line.
right here to this one. Yep, that guy, click to that, get rid of that close out, it's just junk. Okay, and then scroll up a little bit. Okay, stop there.
I'm not sure. Are you seeing this?
They would
No,
if
you stop share.
sharing.
You stop
No.
share.
Oh, okay.
We'll get to that.
You have to stop share. That's my point.
Go back to share,
Go back to share.
yeah, there.
Is that it?
Yeah, but,
Is that it?
well, you wanna, John, go on this website, go this here first. Click that as the background, yeah. There you
A huge hailstorm in Richmond right now.
there you go, and now go,
See, I don't think we're there. Hold on.
We're not.
No, we got to stop.
you gotta stop share, you can't.
Yeah.
Did I hear hailstorm in Richmond?
I didn't get any hailstorms here.
Share, but I don't know.
Yeah.
All right, there you go.
Presentation is it or it's not? No.
Are we back to kind of seeing the 10 days weather?
Is that what it is?
Yeah.
Yeah.
Yeah, okay. So this is, rather than the one that we saw before, this is now today. This is Tuesday. And John's gonna share this website. So this is a fun one. Just if you want to see weather, oopsie. Oh, what did I just do? There we go. This is the 10, so that's the hourly. You can see it by the arrow, but the 10-day to me is more interesting.
Click on it.
Yeah, I am, but it's not letting me.
That's
Well, all right, that's enough. If you want to see it and you want to watch it, it's sometimes too much energy. But the point is that it changes pretty dynamically. And so we're actually going up with some friends to Yosemite